Good evening everyone, welcome to Gate Academy Global. So I hope your day was good and I hope that you have studied well. So our today's topic, yes, good evening Lakshmi, Manish, Suyash. Our today's topic is match filter, as you can see in the title of the lecture, right? So now we are going to discuss about the match filter. Match filter, that means we are going to discussing about the noise in digital communication. So this is the next chapter, noise in digital communication. Good evening Animesh, Shri Krishna, good evening. Rick, good evening. Akansha, Sally. So let's start. So our next chapter is noise in digital communication. Noise in digital communication. Shivani, actually in the morning at the last the buffering issue was there, so net was not working properly. So actually I said I concluded it properly, but it didn't go to you. Before that the net has been lost, so that's why you didn't see that part of the video in which I concluded. So because of the net issue in the morning. Good evening Amal. So our today's topic, as I said, this is a match filter. In match filter, actually why it is used, so let's write that why it is used. So it is used to achieve, it is used to achieve maximum signal to noise ratio, maximum SNR and minimum probability of error. It is used to achieve maximum signal to noise ratio and maximum signal to noise ratio and minimum probability of error. So the match filter is actually used because we want to match the response of the filter with the input signal to the filter. Suppose the input signal is triangular, then we want to have the filter in such a way that is also having the response as triangular. So actually the response of the filter is matching with the input to the filter. So that is why its name is given as match filter. And if it is perfectly matched between the response of the filter and the input of the filter, then we will get the maximum signal to noise ratio, because whatever signal is coming, we are matching the response with the input signal. So definitely we will get the correct output, and if we will get the correct output, the maximum power we will get, and if the power of the signal is maximum, then the signal to noise ratio will also be maximum. Yes, good evening Rakesh and good evening Ankit. So it is used to achieve maximum signal to noise ratio. So what happens is, we give whatever signal we generate to the channel, whether it is a PCM signal, whether it is a delta modulated signal, whether it is a band pass signal like BPSK signal, BFSK signal, any signal, we transmit it through the channel, and in the channel there is a noise. So the noise is always a additive in nature. So most of the time we consider the noise in addition in nature, additive in nature. So if it is the signal SIT and if this is the noise NIT, which is said to be additive wide Gaussian noise. So actually the channel is additive wide Gaussian noise. So that is why No, Ankit, I won't teach the CRC in the crash course. I will teach it separately, or maybe the Neeraj sir is also taking, so he will cover in his crash course. So from there you can complete. Because the match filter is actually the CRC topic is very easy. There is nothing special about the CRC, so that is why. This is the match filter, and the output of the match filter is sampled at any time t, and output of this sampler will go to the demodulator if you are using. And then we will be having, or you can write like this, not demodulator, don't write this demodulator right now. So let's take this as threshold comparator. And we get some output. Okay, so at the input of this match filter, as we can see that the signal and noise are coming. So here we will get the signal SIT and the noise NIT. Signal plus noise we will get, and at the output of the match filter we will get the signal plus noise itself again, and after sampling we will get the sample value of the signal and the noise. So we want to calculate the signal to noise ratio at this point. So we want to calculate the signal to noise ratio at this point, at the output of match filter. So what is happening here? So whenever you will transmit the signal from the channel, there will be some noise which is actually additive in nature. So that noise will add with the signal, and the signal plus noise will be coming at the receiver. So to maximize the signal to noise ratio at the receiver, you will put the filter which will have the response that matches with the input signal. So we are keeping the match filter at the receiver, and this match filter is having input signal plus noise, and this signal plus noise, the corresponding output signal we will get and the corresponding output noise we will get. If the signal plus noise both are coming together, and the match filter, after match filter we will get the signal plus noise, in which the noise content should be less, because we want to have the maximum signal to noise ratio. So actually our requirement would be the noise content should be less. Now after that we sample the signal plus noise, and we compare it with the threshold comparator, and here we will be having some threshold value. So we will compare this particular signal plus noise with the threshold value, and then according to that we will take the decision in favor of 1 or 0. Okay, so now what will happen? Now tell me, what is the power spectral density of white noise? What is the power spectral density of white noise? So the power spectral density of white noise, what is that power spectral density of white noise? power spectral density of white noise is eta by 2 or n naught by 2, whatever you want to write, say n naught by 2 for all frequency. Is it clear to everyone? Yes, eta by 2 or n naught by 2 for all frequency. So we know that the power spectral density of white noise is n naught by 2 for all frequency. Okay. Now this signal plus noise is coming at the input of the match filter. So if the response of the match filter is h of t, then what is the signal? Because signal plus noise are additive in nature, so we can consider the signal and noise separately. Until the signal and noise are additive in nature, the signal analysis can be done separately and the noise analysis can be done separately. So the signal output, let's calculate first the signal power. So our purpose is to calculate the signal power at the output. So to get the signal power, we should have the signal at the output, because we want to calculate the signal to noise ratio at this point. So we should have the signal at the output. So what is that signal that is coming? So starting from here, this S naught T, so output of the match filter S naught T will be H of T convolved with Si of T. Okay. Will it be the output? Output of any filter or output of any system having the response H of T is nothing but the input convolved with the response of the filter or the system. Okay. So S naught T is equal to H of T convolved with Si of T. Now if I take the Fourier transform, so taking this Fourier transform, what we will get? So taking the Fourier transform, we will get S naught of f, that is the convolution will be converted into multiplication. So this is S naught of f is equal to H of f into Si of f. Now if you want to write the inverse Fourier transform, so if you want to write this signal S naught of t, so this S naught of t can be calculated by taking the inverse Fourier transform of S naught of f. And what is the formula of inverse Fourier transform? So minus infinite to infinite e to the power j 2 pi ft df. When we integrate with respect to f, we will get the output as function of time, which is nothing but a inverse Fourier transform of this signal. Now what is the value of S naught f? So S naught f we have calculated here. So we will substitute this S naught t, we will substitute this S naught f in this equation of S naught t, which is H of f, which is Si of f into H of f e to the power j 2 pi ft df. Now this is the signal voltage. What we have got? We have got the signal voltage. Now what is the signal power? So this signal power will be S of t mod square. So we will calculate because when we integrate it, we will get some finite value. How we will get this? H of f e to the power j 2 pi ft df mod square. Now we are only interested at the time where we are taking the samples, because whenever we take the samples, whatever signal we will compare with the threshold, that is important for us, because we are going to take sample at any time. At any time t is equal to capital T. So it doesn't matter that what is the signal at t by 2, what is the signal at 3 t by 4, it doesn't matter. The important point is that when you are taking the sample, you will get the signal voltage, and that signal voltage will be considered as the signal to noise ratio. That signal voltage will be considered in the calculation of signal to noise ratio, because we are taking the sample. So we are taking the sample means we are going to collect some value. So at time t is equal to t, if I say at time t is equal to capital T, if I say, then it should be replaced by capital T. It should be replaced by capital T, and then we will get the power, because when you take the sample of any signal, you will get some constant value. We are not going to integrate it right now, because when you will take the sample, you will get some constant value, so there is no need of integration. And when you get the constant value, how will you calculate the power? So the power of any DC signal, like if you want to calculate the power of 5 volt, that is nothing but a voltage square, that is 25 volt. So tell me whether this point is clear or not. Okay, so this is the signal power which we have got. Now we want to calculate the noise power. So put it equation number 1, and now we will calculate the noise power. So for the calculation of noise power, we will calculate the power is given by the mean square value, because noise is random in nature. So that is why we will calculate the power by random variable concept, and according to this we will calculate the power by adding the variance and mean whole square. Okay, so the mean square value will give you the power of the noise. Mean square value will give you average power. Okay, so now tell me, what is the value of mean? What is the value of mean at the output? What is the value of mean at the output? So the mean value of noise at time t is equal to t is h of 0 and expected value of nit. So whatever will be the response of the filter, what is the mean value of input noise? So this input noise, this input Gaussian noise is having a constant power spectral density, and as we have studied in the random variable or the power spectral density, whenever there is a impulse in between 0 minus to 0 plus in the power spectral density, then only we will be having some non-zero mean value, isn't it? Do you remember this? Okay, so tell me, can you recall this one? We have studied that in the power spectral density, if there is an impulse in between 0 minus to 0 plus in power spectral density, then only we will get some mean value, otherwise the mean value is 0. Do you remember this? Since the power spectral density of this white noise, is constant and having power spectral density n naught by 2, we are not having impulse at f equal to 0. At f equal to 0, we are not having any impulse. So if we are not having any impulse, then the mean value should be 0. So if the mean value of the input noise is 0, the mean value of output noise is also 0. The mean value of output noise is 0, then the mean square value, so output noise power from here output noise power will be variance. Let us represent it by sigma n naught square, and the mean is 0. So the output noise power is represented by sigma n naught square. So sometimes you will see in the notation also the noise power is represented by sigma. So that means that type of question will be having the mean value of the noise is 0. So if the mean value is 0, then the mean square value is equal to variance. So the variance is denoted by sigma n. So mean square value or the noise power will be sigma n square. Yes. So all of you agree with this. Up to this point it is clear, isn't it? Now we have calculated the signal power, we have calculated the noise power. So what will be the signal to noise ratio? So signal to noise ratio is nothing but signal power divided by noise power. Signal power divided by noise power, and the signal power we have calculated, which is mod of minus infinite to infinite SI of f h of f e to the power j 2 pi ft df mod square divided by noise power. So let me write this first. So noise power we have calculated. So noise power is denoted by sigma n naught square, that is okay. But from the match filter, if I say the relation between the output power spectral density and the input power spectral density, so the relation between the output power spectral density, which is Sn naught f, is equal to h of f mod square into Sn I f. Are you agree with this point? Are you agree with this point? The output power spectral density will be nothing but h of f magnitude square into Si of f. Good evening, Subhashri. Yes. So if you want to calculate this output noise power, so we know that area under power spectral density gives power of the signal. Okay. So how can you calculate the power? So if you want to calculate the power, that is sigma n naught square, you have to integrate it from minus infinite to infinite df. So is this point clear? Now we can rub this. So we are discussing about the noise power. First of all, we discussed that noise power is denoted by sigma n naught square. Thus noise power can also be denoted by sigma n naught square. Why? Because the variance is equal to mean square value minus mean whole square, and the mean square value is equal to variance plus mean ka whole square, and the mean of the output of the match filter is 0 because mean of the input of the match filter is 0. So mean at the input of the match filter is 0, that is why output is also 0. So the output is having 0 mean, that means the power will be equal to the variance. So the power will become variance. Okay. And how to calculate this power? So in case of noise analysis, we can calculate the power only using the power spectral density. So power spectral density at the output of the match filter can be calculated by Sn naught of f equal to h of f magnitude square Sn if, where this is the output power spectral density, this is the input power spectral density, and h of f is the transfer function of the match filter. Now we also know that from the property of power spectral density, the area under power spectral density gives power of the signal. So if you want to calculate the noise power, you have to calculate area under power spectral density. So area under power spectral density can be calculated by integrating it from minus infinite to infinite. So we have calculated minus infinite to infinite Sn naught of f df. So this will give us output noise power. So this output noise power can be denoted by sigma n naught square. So is it clear? Now let's substitute the value of noise power here. So we will substitute the noise power, which is minus infinite to infinite, and the value of Sn naught of f. The value of Sn naught of f is nothing but h of f magnitude square into Sni of f df. Okay, one step you can write here also. If you will substitute this value, so you will get sigma n naught square is equal to integration from minus infinite to infinite h of f magnitude square into Sni f df. So this is how we can write. Okay, now how to perform this integration or how to solve this type of integration? For this we are having one inequality which is known as Schwarz inequality. This is known as Schwarz inequality. So this inequality says that if we are having this type of function which is minus infinite to infinite x of f multiplied with y of f and df magnitude whole square, so this integration will always be, that means this integration will always be less than equal to integrating the minus infinite to infinite x of f mod square df and minus infinite to infinite y of f mod square df. Okay, so this is the inequality, and for maximum value for equal sign, here we have written the less than value. This term can be equal to this term for equal, for equality, for equal sign, this y of f is k times of complex conjugate of f, where k is called some arbitrary constant. So this is the inequality. This inequality says that if you have this type of integration, then this term will always be less than, this term, left hand side term will always be less than this term, right hand side. Okay, and it can be equal, that means it will give you the maximum value. We are saying that if there is no equal sign, it means this value will always be less. So what is the maximum value of this left hand side? The maximum value of left hand side will be calculated when there will be equal sign. So if you want to write equal sign, then for equal sign you have to satisfy one more criteria, and that criteria is y of f should be equal to k times of complex conjugate of x of f. Clear? So if you don't use equal sign, so this integration will always be less than equal to right hand side. Okay, so that means this value will always be less. So what is the maximum value of left hand side? The maximum value can be equal to this term, but when you use the equal sign, you have to satisfy one more condition, and that condition is y of f is equal to k times complex conjugate of x of f. Okay, it is clear? Okay, so let's apply in our case. So in our case, this signal power, which is S naught square T, and the noise power, which is sigma n naught square, that is the notation, that will always be less than equal to. So this integration is less than equal to what? Less than equal to, if it is x of f and this is h of f. So we are assuming the x of f and h of f, y of f. So x of f is Si of f magnitude square df, and the y of f is minus infinity to infinity magnitude of h of f e to the power j 2 pi ft df whole square. Sorry, h of f, yes, it will be magnitude square here and then df. This will be the numerator, and the denominator is minus infinite to infinite Sn I of f and h of f mod square df. Okay, so tell me, are you agree with this? Okay, now we are assuming what? We are assuming this term as x of f and these two terms as y of f. So we are having these two terms, x of f and y of f. So according to this inequality, this x of f is Si of f, so we have substituted this, and y of f we are considering h of f e to the power j 2 pi ft, so we are here writing it here. Now if you take the magnitude of this, the second term, what will get? S naught square divided by sigma n naught square is less than equal to, it is minus infinite to infinite Si of f mod square df, and the second term will become minus infinity to infinity h of f magnitude square df, and divided by the power spectral density Sin I of f is nothing but the power spectral density of white noise. So the power spectral density of the white noise is n naught by 2, and it will be minus infinite to infinite h of f mod square df. So what we are getting is these two integrations will get cancelled, and we will get S naught square T divided by sigma n naught square less than equal to 2 divided by n naught, and integration from minus infinity to infinity Si of f mod square df. So tell me, up to this point it is clear to everyone? Okay. Now what is this term? What you will call this term is nothing but, if I ask you to calculate the energy of any signal, say SIT, energy of any signal, say SIT. If you want to calculate the energy of SIT, how you will calculate? So the energy of SI is, if you will integrate it from SIT from minus infinite to infinite, you will get the energy. Or using the Parseval's theorem, you can write this SI of F mod square dF. You can calculate the energy by this. Okay, so this term can be written as energy of the signal. So the response of the signal to noise ratio of the match filter is 2 times energy of the signal which is input to the match filter, divided by power spectral density. And what is the maximum value of this term? So the maximum value S naught T upon sigma n naught square will have its maximum value when it is equal to 2 ES upon n naught. So this is the maximum signal to noise ratio for match filter. Signal to noise ratio for match filter is 2 ES upon n naught. So because we have used the equality sign, because we know that this signal to noise ratio is always less than 2 ES upon n naught. So what is the maximum value of signal to noise ratio? The maximum value of signal to noise ratio will be 2 ES upon n naught when we satisfy the equal condition. So when you are using the equality condition, you have to satisfy one more condition. So according to this condition, what we will get? So according to this condition, if we substitute y of f, means we are having h of f, here we have written y of f, h of f e to the power j 2 pi f into t equal to k times complex conjugate of x, means si, the complex conjugate of si. Now this will give you the transfer function of the match filter. So the transfer function of the match filter, you can calculate h of f is equal to k times si of f complex conjugate and e to the power minus j 2 pi f capital T. So this is the transfer function of the match filter. Now if we want to calculate the response of the match filter, impulse response of the match filter, so how can we calculate the impulse response? How will you calculate the impulse response? If we want to calculate the impulse response of the match filter, impulse response of the match filter, impulse response of matched filter is by taking the inverse Fourier transform. So by taking the inverse Fourier transform of h of f, so we will get 2 pi ft df. So by taking the impulse, by taking the inverse Fourier transform, we will get the impulse response of the match filter, and we are having h of f. So we can substitute this h of f here, and minus infinite to infinite h of f is k times Si of f, that is complex conjugate, e to the power minus j 2 pi f capital T and e to the power plus j 2 pi f small t and df, and it is h of t. Now if I solve it, if I further solve it, it becomes k which is a constant, minus infinite to infinite Si of complex conjugate of f, here e to the power j 2 pi f, and let us say minus sign common. So if I take minus sign common, it will become t minus t and df. Okay. Now for any practical filter, to be realized, if you want to realize the filter practically, then the response of the filter should always be real. For physically realizable of any filter, response of the filter should be real. Response of filter should be real. So what is the meaning of this? So the meaning is h of t and its complex conjugate will be same. H of t and its complex conjugate will be same. The real means h of t and its complex conjugate will be same. The value 5 is a real number. If I take the complex conjugate, I will get 5. If there is a complex number, if I take the complex conjugate, I will get 5 minus 2j. Okay. So this is the real number, this is the complex number. So from here we can see that if we take the complex conjugate of any real response or real filter, you will get the same thing. So if I take the complex conjugate both the side, what I will get? So the complex conjugate of h of t, I am taking complex conjugate both the side, you will get k minus infinite to infinite Si of f. If I take the complex conjugate of this, you will get the real value again, and if you take the complex conjugate of this is e to the power j 2 pi f capital T minus small t and df. Now from here, because we have already written that for physically realizable of any filter, h of t and its complex conjugate are equal, so the left hand side will become h of t again, and this k times, what is this formula? This is the formula of Si of capital T minus small t. See, if, understand this point, if we are having the t here in the formula of inverse Fourier transform, this is the formula of inverse Fourier transform, and in the inverse Fourier transform, if it is t and whatever function is here, that is h, we keep it in the argument of small h, that is its inverse Fourier transform. Okay. So if it is t, we kept it in the inside of the argument to get the inverse Fourier transform. So this t will be substituted in the argument where at inverse Fourier transform. So here we are having the capital T minus t. So the capital T minus t will be kept inside the argument. So the capital T minus t is inside the argument of inverse Fourier transform of this signal. So the inverse Fourier transform of h of f is h of t. Similarly, inverse Fourier transform of SIF is SIT. So that SIT should be replaced by capital T minus t. Now tell me whether it is clear or not. Okay. Now it means that whenever you are having the match filter, okay, in the question suppose you are having the match filter and we are having the input say x of t and we are having the output say y of t and the response of the filter is suppose h of t, then the output y of t is x of t convolve with h of t. Now this h of t shows that the response of the match filter, is nothing but the input of the signal shifted by capital T minus t or the shifted by t. Okay, so this SI was the input to the match filter and now it has been shifted by t. Similarly, the response of the match filter in this case the input is x, so it should be shifted by capital T minus small t and keeping the arbitrary constant k as 1. If it is not given, then you can take the arbitrary constant k equal to 1. So if you want to calculate the output of the match filter, you have to convolve the input to the match filter with the response, which is nothing but the shifted version of the input signal, So response of the match filter is nothing but the folded and shifted version of the input signal, and once we get the folded and the shifted version of the input signal, that is nothing but a response of the match filter, and this match filter response gets convolved with the input signal and will give you the output of the match filter. Thank you, Ayush, and all the best for your exam. So have you understood this point? So in simple way, the conclusion of whole discussion is, if there is a match filter and input to the match filter is x of t, and the output of the match filter is y of t, and the response of the match filter is h of t. In the question, they can ask you for the response of the match filter or output of the match filter. Response of the match filter means h of t. This is impulse response. So impulse response of the match filter is nothing but the input signal which is folded and shifted. So the input signal, folded and the shifted version of the input signal is nothing but the response of the match filter. Folded and shifted version of the input to the match filter is nothing but the impulse response of the match filter. And once you get the impulse response of the match filter, by convolving it to the input of the match filter, you will get the output. So once we get this h of t, we can convolve with the input and we will get the output. So in the match filter, we generally get these two type of questions. They can ask you for the response of the match filter, or they can ask you the output of the match filter. Now, for example, if there is a match filter at the input we are having x of t, and this input is having the amplitude A and duration t. Okay, this is the input. Now we want to find this h of t and we want to find this y of t. So I am giving you one example. In this example, we are having the match filter, and at the input of the match filter, the x of t, at the input of the match filter, x of t is the input which is given in the diagram. It is asked to calculate the response of the match filter and the output of the match filter. Yes, optimum filter is there in the GATE syllabus, that we will discuss tomorrow morning. So how will you draw this signal? How will you draw this signal? So first of all, we will draw x of minus t. So x of minus t means you will get this signal. X of minus t means you will get this. X of minus t, you will get same this signal. And this minus t signal is actually delayed. Actually it is advanced operation, but because we have folded the time axis, we have changed the or inverted the time axis, the delay operation will become advanced and the advanced operation will become delay. So after folding, this is the folding operation. Okay, so this is the folding operation, and after folding we are actually advancing the signal, but after folding the advanced operation will become delayed signal, and the delayed signal by t, will be same signal. So this is the response of the match filter. So first thing we have calculated, the response of the match filter is nothing but same as the input signal. Okay, so it is same as the input signal, same as input. response of the match filter is same as input. Now it means that it is perfectly matching with the signal which is input to that match filter. Now to get the output y of t, we will convolve x of t with x of capital T minus t. So this is x of t, this is x of capital T minus t. So if you convolve these two signals, because this is a symmetrical rectangular pulse, after convolving, what you will get? After convolving these, what we will get? We will get the triangular signal. Okay, so if two symmetrical rectangular pulses are convolved, we get the triangular signal, and this triangular signal will have the minimum value 0, which is the addition of minimum value of these two, and the maximum value, which is the addition of maximum value of these two. So this t and t, after adding these two, we will get the maximum value 2t. So this is the t, and the intermediate point is t. Now what should be the slope? What is the slope of this? Slope is, what should be the slope? The slope is nothing but the multiplication of height of two rectangular pulses. So the height of two rectangular pulses are a and a. So we will multiply this, and a into a is a square. So the slope of this triangular signal will be a square. So because of this, the height will become a square t. The height will become a square t. So what is the maximum amplitude of the input signal, output signal? Maximum or peak value of output of match filter. Tell me, maximum or peak value of output of match filter. What is that value? Maximum or peak value of output of match filter. What is the maximum or peak value of output of match filter? Yes, Animesh. Yes, Nilanjana. Balakrishna. So the maximum amplitude is a square t. The maximum amplitude of the output signal is a square t. Now suppose I calculate energy of the input signal. If I will ask you to calculate the energy, what is the energy of the input signal? So the energy of input signal is ES is equal to minus infinite to infinite x of t magnitude square dt. This is the formula to calculate the energy. So what is the magnitude? So the x of t will exist up to 0 to t, so the limit will be from 0 to t. Amplitude is a and a square dt. So after solving this, we will get a square t. So the maximum or peak value of output of match filter, the maximum value is a square t at the output, and this a square t is equivalent to the energy of the input signal. So this is very important point, and this is a point to be noted, that maximum or peak value of output of match filter is equal to input of energy of input to the match filter, energy of input to match filter, energy of input signal. energy of input signal. Energy of input signal. Okay, so this is always true. This point is always true. Okay, for any kind of signal, this is just an example, and in the example we have taken this rectangular pulse, but this is always true that whenever you give the input to the match filter, the energy of the input to the match filter will become the peak amplitude of output of the match filter. Okay, energy of the input signal to the match filter will become the maximum amplitude of output of match filter. Now the second thing, at which time instant or at what time instant this maximum value is achieved. Yes, Akansha will do right now. After 5 minutes we will solve some questions also. So my question is, at what time instant we are getting the maximum amplitude at the output? So we are getting the maximum amplitude, we are getting this maximum amplitude at time t is equal to capital T. And what is this capital T? What is this capital T? Okay, so peak amplitude of output of match filter occurs at total duration of input signal. Total duration of input signal to the match filter. Input signal to the match filter. Yes, time duration of input. You can see that the total duration of the input signal, the total duration of the input signal was t, and at time t is equal to t, small t is equal to capital T, we are getting the maximum amplitude. So these 2 points are important to solve questions. Time duration of the input signal. Okay, yes, Balakrishnan. So the time duration of the input signal is capital T, and at that particular instant only you are getting the maximum amplitude of output of match filter. So let's solve the first question. So this is the question in front of you. So the question is, consider the pulse shape as shown in figure. The impulse response h of t of the filter to the matched is. Filter matched is. So in this question it is given that, so this is the response 0 to t and having amplitude 1. So now we have to calculate, this is s of t is given, and this is nothing but the input to the match filter. Okay, so it is given as input to the match filter. In the question it is asking about the response of the match filter. So the response of the match filter is just, you have to write or you have to draw h of t is equal to s of capital T minus small t. Okay, so this is the question. So the question is, we are having one signal which is input to the match filter, and the shape of this signal is total time duration t, and this is a triangular signal and it is input to the match filter. Now we know that if any signal is given to input to the match filter, then the response of the match filter is nothing but its folded and shifted version. So how to draw this? So I think you are able to draw. If we fold it, we will get this triangular signal. If we fold it, so to fold this signal, we will divide it by -1. So the whole axis is divided by -1, so we get minus t to 0, and now it is s of minus t. Now if we want to shift it by capital T, so it will shift towards right, and when you will shift towards right, you will get 0 to t, and this is t, and it will become h of t, which is s of capital T minus small t, and the amplitude will remain 1. I hope you are able to draw this type of signal. Yes, so all of you have given the correct answer, option C. Okay. So let's discuss another question. Yes, so this is the question number 2. So the question is, the input to a match filter is given by S of t, the peak amplitude of the filter output. The peak amplitude of the filter output, yes. The peak amplitude of the filter output, okay. So we have to calculate the peak amplitude of the filter output. So we have already seen that the peak amplitude of filter output is equal to energy of input. Okay, so the energy of input. So we are having this signal, So what is the energy of this signal? So the energy of this signal is A square, or you can say the energy of the signal can be written as power into time, power into bit duration, or the time you can write. So what is the power of this sinusoidal signal? The power is 10 square divided by 2. And what is the duration? So the duration is only, it is existing for 10 to the power minus 4 second. Okay, it is existing only for 10 raised to power minus 4 seconds. So energy is equal to power into time. Energy is equal to power into time. So from here you will get 50 into 10 to the power minus 4, or you can write 5 millivolt. So the correct answer for this question will be 5 millivolt. Now solve this question. Consider the signal x of t shown in below figure. Let h of t denote the impulse response of the filter match to x of t, with h of t being non-zero only in the interval 0 to 4. Okay, and we have to calculate the slope of h of t in the interval 3 to 4. So all of you have given the answer B, that is -1. Okay, so let me draw the signal first. So the signal which is input to the match filter is 1 0 1, it is 0 1, so here we are having this 2, then 3 and 4. Okay, so I have drawn the question. Yes, so all of you are able to give this answer. Very good. Okay, so let me draw this response of the filter. So the response of the filter h of t is equal to x of capital T minus small t. What is the duration of the pulse? So the duration of the pulse is 4. So the total time duration is 4 seconds. So that means we have to draw 4 minus t. So we have to draw 4 minus t. So let's draw x minus t first. X of minus t. So if I draw x of minus t, that is the folded version, so it will look like this. Okay, so this will be at -1, this will be at -2, this will be at -3 and -4, and it will become t. Okay, whatever will be the amplitude. Amplitude we will write later. I think the amplitude is 1 and -1, right? Okay, 1 and -1. So the amplitude is, this is 1 and this is -1 now. Now we have to shift it by 4. So we have to shift it by t is equal to 4. So actually it is advanced operation, so again it gets delayed because we have folded it. So when you delay it, you will get the signal which is like this. Okay, so this is 1, this is -1, it is 0, it is 1, it is equal to 2, it is equal to 3, and this will become 4. So we have to calculate this slope. The slope is height is 1 and the base is also 1, but the slope is negative, so we will get the -1 slope. So we will get the slope -1, and those who are not able to calculate this slope, that is 3, 1 and it is 4, 0, and the slope is y2 minus y1 divided by x2 minus x1. y2 is 0, y1 is 1, x2 is 4, x1 is 3, so we will get -1. So the slope is -1. So all of you have given the correct answer, so that is very good. That you actually, this is just the concept of the signal, because match filter response, just you have to know the match filter response. After that you have to just apply the concept of signal, and that too just you have to draw the signal, how to draw the signal, just that you have to apply. Okay, so let's solve another question. Now solve this question. So all of you have got the answer, I think. Yes, option C you are getting. So let's discuss the question. So let me draw the question first. So the waveform which is given as amplitude is between 1 and -1, and it is 0, 1, 2. Okay, so this is 1 and -1, and it is 0, 1 and 2. It is given to the input of the match filter, and we know that the output can be calculated by convolving the input with the response of the match filter. So we know that how to draw the response of the match filter. Since this is the having the total duration 2, so let's draw it directly. So we can write x of 2 minus t. Now you are aware how to draw this. Okay, so the folded and the shifted version, so it will look like this: 0, 1 and 2, and it is +1 and it is -1. So this is the response of the filter. So we are having x of t and h of t. Now we have to convolve these two signals. So how will you convolve these two signals? So to convolve these signals, this y of t, to get this y of t, you have to convolve this x of t with x of capital 2 minus small t. So for this we will write it in terms of unit step signal, and when we write it in terms of unit step signal, what we will get? Now tell me what we will get. Okay, so let's write it in terms of unit step signal. This ut minus 2 ut minus 1 plus ut minus 2. Okay, so it should be convolved with u minus u t plus 2 ut minus 1 minus ut minus 2. Yes, exactly. Okay, so yes, Manish. Okay, so when we convolve, what we will get? When we convolve the unit step signal with the unit step signal, what we will get? We get the ramp signal. So what we will get? The ramp signal with negative slope, because this ut is going to be convolved with this ut. So ut convolved with ut, you will get the ramp signal with the negative amplitude, and ut convolved with this ut minus 1, you will get plus 2r t minus 1, and then minus r t minus 2. So this first term convolved with all the three terms, you will get the ramp. You will get the ramp, and that ramp will be shifted according to the shift in the unit step. So this is ut, this is ut, you will get the ramp. This is ut, this is ut minus 1, you will get the ramp but shifted to t minus 1. And this is t minus 2 and it is ut, so you will get the ramp which is shifted to 2. Okay. Now when we convolve these two, that means the second term is convolved with all the three terms, you will get minus minus become plus rt minus 1, and this plus minus 4 rt minus 2, and then minus minus become plus rt minus 3. Now the last term will get convolved with all the three terms, we will get minus r t minus 2, minus r t minus 2, and when it will convolve with this is plus 2 r t minus 3, and this is plus and this is minus, we get minus r t minus 4. Is it clear? So if we write it minus RT. And RT minus term, how many terms are there? RT minus 1, this is 2 RT minus 1, this is also 2 RT minus 1. So we will get 4 RT minus 1. Then how many terms are there with RT minus 2? This is minus 4 RT minus 2, this is minus RT minus 2, minus RT minus 2. So overall minus 6 RT minus 2 plus 2 R, this is plus 2 and this is plus 1. So we will get 3 RT minus 3 and minus RT minus 4. So tell, is this correct? Is this line is correct? Yes. So what is the overall slope? Now when we convolve these two, we will get the output, which is a ramp signal. This is the output y of t, and this y of t is starting from 0, because RT means it is starting from 0 and it is having the slope. What is the slope? That is minus 1. So this is having the slope minus 1. So slope is minus 1. Slope is minus 1. So this is the slope, which is minus 1, and this term is having the slope plus 4. So the equal is the addition of the starting to ramp function will give you the slope, which is 3. When you add these two, when you add this ramp with this ramp, you will get the ramp signal, which is having the slope plus 3. So you have to draw the signal having the slope plus 3. So you have to draw the signal or the ramp which is having the slope plus 3. So it should have the slope plus 3. And where we are applying? So we are applying at 1. It is 0. What should be this height? What should be this height? This height should be 1 minus 1, right? To make the slope 1, this height should be minus 1. Now, what should be the height? What should be this height? What is this value? What is this value? So the slope is 3. So the slope is 3. And we know that the slope is y2 minus y1 divided by x2 minus x1. We know the coordinate of this point, which is minus 1, 1, means 1 minus 1, and we don't know about its y coordinate, but we know that this is going to change at t is equal to 2. So this is at 2. So we are having the coordinates 2 comma y. So when we apply y2 minus y1 here, so we will get 3 is equal to y2 is y, y1 is minus 1, x2 is 2 and x1 is 1. So it will be equal to 3 equal to y plus 1. So we will get y is equal to 2. So it means this maximum value will be 2. This maximum value will be 2. Yes, correct. So now at t is equal to 2, at t is equal to 2 here, at t is equal to 2, the slope equivalent slope was 3 and here the slope is minus 3. Now the slope should be minus 6. Then now the slope should be minus 3. So that was the line having the slope plus 3. Now you have to draw at time t is equal to 2 the negative ramp, which is having the slope minus 3. So it is having the slope minus 3. It is having the slope minus 3 up to this point. Now the slope is changing here, minus 3 and the slope is plus 3. So minus 3 plus 3 will become yes, minus 3 plus 3 will become 0. Why it is so? Is there any calculation mistake? Four RT minus 3. Why 4 RT minus 3 is coming? That what I have missed, I think I missed this point. So when we multiply this with this, okay, so it is plus 2RT minus 3. It should be plus 2RT minus 3. So this is plus 2RT minus 3, this is plus 2RT minus 3, so it should be 4. So if the slope is 4, then 4 minus 3 is equal to 1. So you should have the positive slope at 3. You should have the positive slope at 3. It should go like this. But at point t is equal to 4, at 4 we are applying 1 minus 1. So the slope is now 0. So it is 0. Okay, so this is having the slope, 1 and it is having the slope 0. So total we are calculating 1, 2, 3, 4, 5 slopes. So we are having the 5 terms 1, 2, 3, 4, 5. So overall we are having the 5 terms, and in this way we can draw the signal. So according to this we can tell our option, and the correct option was option C. Option C was the correct answer. So let's solve the next question. So the next question is, this is the next question. Abhishek, you are getting option C. Shruti Goyal, yes. Manish, you are getting D. So let me draw the question. So PT is equal to UT minus UT minus 1 is given. So UT minus 1, that is nothing but a rectangular pulse of width 1. So that is a rectangular pulse of width 1. This is PT. And the GT is PT convolved with PT. Now input to the match filter is S of t is equal to, input to the match filter is S of t is equal to GT minus del t minus 2 convolved with GT. Okay, so this is the question, and we have to calculate the impulse response of the match filter. Okay, we have to calculate the impulse response of the match filter. So in this question it is given that the PT is equal to UT minus 1. So if you draw the UT minus 1, you will get the rectangular pulse, and this rectangular pulse is having width, height is 1, and when we convolve the two rectangular pulse we will get the triangular signal. So we will get the triangular signal which is having the duration 2 and the height is 1. But our signal which is input to the match filter, so the signal which is input to the match filter is GT minus delta t minus 2 convolved with GT. So whenever we convolve any signal with the impulse function, we will get the signal itself. So when we convolve this signal with the impulse, we will get the signal itself, but it will be shifted to 2. So the signal which is input to the match filter is GT minus 2. So first of all we have to draw the GT and GT minus 2. So this is GT. So what is that GT minus 2? So it will be shifted version. So let me draw like this. Let's draw from here. So this is GT minus 2. So it will look like this. Okay, so 2 to 4 you will get, and it is 1. So GT minus 2. When we add these two, we will get the signal which is input to the match filter. So the input to the match filter will be this, and because actually we have to add the signal but with the inverted version. So when you invert it, you will get the signal which is inverted from 2 to 4, the triangular signal which is inverted from 2 to 4. Is it correct? Is it correct? The input to the match filter. This is the input to the match filter. Okay. So here the question is, this is the match filter and the input to the match filter is S of t, and now we have to calculate this H of t. What is the response of this match filter? Okay. Now what is the duration? So the total duration of the input to the match filter is 4. So the total duration is 4. So the response will be H of t is equal to S of capital 4 minus t. So S of capital 4 minus t when you draw. So let's draw S of minus 4 first. So when you draw the S of minus 4, you will get, S of minus t, you will get this S of minus t. Okay. So this is S of minus t, this is minus 1, minus 2, minus 3, minus 4. This is s of minus t. Now you have to shift it by 4, so it will get delayed, and it will be ranging starting from the 0, and it will go up to 4. So this is the response h of t, which is s of 4 minus t. So we have to tell the response of the match filter in terms of input signal. So this is the input signal. So this input signal, how it is related with this response. So we can see that if we invert this, if we do the amplitude inversion, this positive amplitude will become negative, and this negative amplitude will become positive, which is nothing but your response. So now you can say that this h of t is nothing but minus of s of t. So the minus of s of t will be the correct answer, that is option C. Okay, I think it is clear to everyone. Okay, very good. So that is it for today's session. So we will continue tomorrow morning, and we will be discussing about the optimum receiver. Okay, so we will be discussing tomorrow about the optimum receiver, and we will calculate the probability of error when the noise is Gaussian in nature. When the noise is Gaussian in nature, we will calculate the probability of error, and we will also discuss about the optimum receiver that gives minimum probability of error. So we will discuss about the value, threshold value, how to decide the threshold value, what is the condition to decide the optimum threshold, and the optimum threshold gives minimum probability of error. So we will discuss about all this, and maybe we will also solve few questions in the morning itself, or we will be solving the questions in the evening. The probability of error question, that is the most important part of the digital communication, we will be discussing tomorrow in the morning and the evening. So, and that will be all about our noise in digital communication. Okay, so in the tomorrow session we will be finishing the noise in digital communication, and from the Monday or Tuesday onwards, we will discuss some basics about the information theory, and after that we will finish the crash course of the communication system, and later on we don't know what will happen, what will start. So in the Tuesday, maximum the Tuesday, we will be finishing our communication system crash course. Thank you Niranjana, welcome dear, and Shivani, yes, the tomorrow timing, morning timing is 9:30. Link is already present in the Gate Academy channel. You can go and see the link I have already created for the morning session. So tell your friends, okay, to come in the morning session also at 9:30. Thank you Suyash. Thank you Manish. Thank you Rick. Love you dear. Thank you Shri Krishna. Akansha. Warm welcome all of you. Okay, so we will continue tomorrow in the morning 9:30. Okay, and Anything else? In the information theory, we will not discuss about the coding part. We will be only discussing about the information theory and the conditional entropy, joint entropy, etc., and also the channel capacity. That will be finishing in the 2 days. So in the Monday and Tuesday, we will be finishing the information theory. Okay. Okay then. See you tomorrow. Love you all. Good night.